Hey everyone, with you Elena Litvinova, and in this video we will study how to write algorithm binary search for sorted array, and we will study about this algorithm, how it can help us to find information much faster. For example, if we will compare with linear search, yes. Yeah, and everything we will check, we'll speak, we'll draw and write this algorithm with in JavaScript language. Okay, but before we will start, not forget to subscribe on this channel, press bell icon and go. Okay, let's try to understand what is binary search. If you go to Google and try to use any website, binary search is a searching algorithm used in a sorted array by repeatedly dividing the search interval in half. Okay, now binary search, how I understood, it is a search algorithm for sorted array. For example, we have an array which is sorted. And it can be really different array with numbers, and we need to write a function binary search, and here we just pass this array and search number. We also can, for example, console.log and call this function. We can pass array here already, and for example we try to find any element here. And how we can find this element? For example, we can try to check every single number in this array from the start. For example, to check 1 is equal 5, no, 3 is equal 5, no, 5 is equal 5, yes, return. Yes, for example, return index this element. In the worst case, we will need to go through all this array and to check every element. For example, if we try to find 21 number, yes, and it means that time complexity will be equal big O of n. It means that we need to go through all this number. For example, for let e is equal 0, e less than r length, I plus, and we just check r at I is equal search number, and if it is, then we return this element, return I, for example. Yes, in other case, if we found nothing, we return false, for example. But if for example we have in this array really a lot of elements, I don't know, 1 milliard elements. For example, we have a social network, Facebook or another one, and we just need to find a user. We have IDs of all users, they all sorted, and we just need to find information about one user. And we have database where there are, I don't know, 1 billion users. And what we should to do, we should to check, for example, each element, and it could be really long to find this element. And binary search algorithm say us that we can find any element in sorted array for time log n. Base here is 2, and n is a count of operations. For example, if we have 1000 elements, we will find our element. It's around for 10 iterations. Yes, it's really cool. Or if you have 1 million, sorry, we need to go through this array just 20 times. If we have 1 billion, 1, 2, 2, yes, just 30 iteration we should do to find this element, no 1 milliard. It shows us how fast this algorithm can be. Okay, how it works? Now let's go and try to explain more. For example, we have an array from 0 to 100, and we need to find 37. Yes. What we should to do? First of all, we can divide this array on half. If we have all numbers here will be around 50, yes? And after it, we compare this number with 50. Is it less or greater than 50? And we understand that 37 is less than 50. So we can remove all this part half of array, just because we exactly know that 37 now in this part. And after it, we need to look for this element in this part. After it, we again work with this part of array and again divide on 2. And here's 25, yes? We compare 37 is equal 25, no, but 37 is greater than 25. It means that 37 not here because we have sorted array, how we remember. And after it, we divide on half this part, for example, and if we divide on half, it will be 37 and 2. We round it into floor, and we have 37 in the middle. We compare, okay, we return this element, we found it. And how you see, we just check 1, 2, 3. To find 37 element, we just needed 3 iteration here. 3 iteration. Okay, and this algorithm is binary search. Let's try to create this algorithm. Okay, there are a lot of different approaches how to write this, but I really liked one approach which I found on one channel, which is Russian one, channel by Viktor Karpov, and I just show you this example. I really like this approach. Okay, what we have for now? We have an array, and we set left and right borders. We put left is equal -1. We remember that each array starts from 0. We have right our length. This is left border, right border. Because we start from 0, our last element will be array length -1. So we have left and right borders. After it, we need to go through one loop where we write minus left is more than 1. We will move left border to the right, right border to the left, and in one moment when we go divide, in one moment we got that right and left border will be on the same place, and because of it we have this comparison. Okay, and what we need to do next, we need to find middle is equal math floor. Here what we need to do, we multiply left plus right. For example, we have 5, we have 19, yes? We multiply left border and right, this is indexes, and divide on half. And it means that we, with this formula, if we have this and this element, we will have index between them, not go to the left side or right side. Okay, we found our middle, and after it, what we need to check? If such number is equal r of middle, we just return such number. I mean middle, sorry, index, yes? If such number less than r of middle, so we found middle and we understand that such number is less than middle. It means that we have to say that right is equal middle. We move right border. Because, for example, we're looking for 5, we divide on half. We understand that r of middle it is 18, 5 is less, so we move our right border. In other case, if search number is greater than our middle, we move left border and say middle. So for example, if we found 3, we have search number is 5, we need to move our left border, because here we definitely not have this element. And actually this is algorithm what we have, and we could check that this algorithm works. And we found 5, 0, 1, 2 on position 2. Also we can add here count of iterations, for example 0, and to check how many iterations just we have to find our element, and we just can return an object, for example AD, and here as well return this. Only false we put here. Okay, and now index.js, and we have just 3 iterations to find our element here. If we need to find, for example 21, we have 4 iterations. In this array we have 1, 2, 3, 4, 5, 6, 7, 8 elements. It means around 4 iterations we need for 9 elements. If we try to find, I don't know, something which is not exist in this array, we also have a 4 iterations. This is maximum, and we return false because there is nothing was found in this array. And this is binary search. I hope that this video was really interesting and helpful, and of course not forget to subscribe on this channel, press bell icon, subscribe button, write comments if you have any question, or just, I don't know, put heart in comments. This is your Elena Litvinova. See you in next video. Bye bye.